Hello and welcome to STW's training video on KFX Winflash. My name is Joe Stevenson and I'm going to be covering how to properly set up Winflash and then actually flash your controller, your STW controller. There's two typical uses for Winflash. The first would be a programmer who's doing bench testing, so they'll need to repeatedly flash the controller to test their changes. And the second use is someone like a service tech who's loading software on a controller before it's installed on a vehicle. This training assumes that you've got a Windows PC with the STW CAN software installed, and also that you're using a USB to CAN dongle and a programmable STW controller. In this training, I'm using the Peak Systems CAN dongle. That's our standard STW dongle that we sell. We also support we have drivers to support other dongles such as the XHAT or Vector, and those can be found in the STW CAN folder for our CAN drivers. So the first thing we'll do here is we will open Winflash. And starting from the top down, we're going to first look at the communication driver to make sure we've got that properly set up for our dongle. So we're going to click select, and here you can see the default directory for the Peak driver is C Windows System 32, and then it's called stwpeak2.dll. That should be the default, and you should be able to find it there if you're using the Peak Systems driver. So we can also click configure here, and this will allow us to select a CAN network that we're going to flash over. The default network is testnet, but if it doesn't exist, I believe the program will prompt you to create it when you start Winflash. Otherwise, you can click create here and type in a name for a network and then click OK, and it'll create that network in this list for you. Also, this is the default bitrate that the program will use to flash the controller on this particular network that you've chosen. The other settings here, we don't really need to worry about at this time. We're just going to look at these two here, the network and bus rate, or bit rate. So click OK here, and OK to save your driver settings. Just a side note, the configure button here also brings you to that setup menu that we were just on. So we can cancel out of there. And next, let's move to actually selecting our hex file that we're going to flash. So you click select on here, and the default directory for Codesys 2.3 at least is C program files, 3S software, Codesys 2.3, compile, and it will put your hex files in there unless you've told Codesys to look for a different directory when you made the program. So for now, I'm going to just choose one of my hex files here. You can see this is for an IOXP controller. It's one of our 16-bit controllers. So I'm going to click open, and that will tell the program to use that hex file. The view button is for viewing information about the hex file. It's got some basic information, but if you use the library, which allows you to add more information here, it will show the other information you've added, such as type of device and version number, etc. Okay, now that we've selected our hex file, we're going to look at some of the configuration options here. You'll see two tabs, flash parameters and advanced parameters. So first, flash parameters, we've got the local ID, and this is an ID which the Winflash will look for the controller on, and it's something that can be configured. So for example, if you want to have two different controllers on your bus, you could set them up for different local IDs, and then you could flash them individually based on local ID. And we'll get into a little bit more of that here in a minute. I'm just going to look through or run through the other options here. Next is company ID. This is a 2 or 3 digit code, which is a security measure we've implemented into our controllers so that only those who know the company ID can communicate with the controller through KFX Winflash. Next, the send ID is the CAN ID on which Winflash tries to communicate with the controller. Please leave this at its default setting. Okay, next we've got bitrate. Again, this is the bitrate at which Winflash will try to communicate with the controller on the CAN bus. Typically, the bit rates are 125 or 250 are the most common bit rates that we flash at. I believe when you order a controller, it will default to 125. If that does not work, please try 250 or refer to whatever bus rate you've set up. Lastly, we've got the type of hex file here. The newer controllers, such as the IOXP or the 3XL and 3XM, use the automatic method of flashing, and this will automatically determine what sectors are needed to flash based on what type of hex file you've given in either an application or a runtime system. If you've written your program in C, you can choose the C application item here, and this will flash all sectors. And then for our older controllers, such as an SX Lite or an SX Micro, you can select either the IEC 1131 application or runtime system, and this will force only specific sectors to be flashed based on the type of hex file you've got here. So for this application, again, I'm using an IOXP, and I will choose automatic. Okay, so now we can move on to actually flashing the controllers. And the center of the program here has three options. The search nodes and flash nodes buttons are the actual flashing buttons, but the middle one here will let us configure some items before we flash it. So my controller right now is set up for 250, and before we do that, let's look at the advanced parameters, because there is a timer that will run here. It'll fill up this progress bar when you start flashing. And this is the time in which you must turn on the controller to start communication. So you must have the controller off first, and then once you click one of these flash buttons, you turn the controller on before this time runs out. So this start time here is configurable, and it's the amount of time that you have to turn the controller on before Winflash stops its communication with the bus. So for instance, if you were on a vehicle where your laptop connection to the CAN bus was pretty far away from the cab where the ignition switch is, you could set this to something like 10 seconds to give yourself enough time to hit flash and then walk up to the cab to turn the controller on or turn ignition on. So once you've set your start time to the desired time, we're ready to flash now. So we can come in here, and first, as I said, I'm going to show you the configuration menu. So I'll turn my controller off first, and then I'll click Configure Node and turn the controller on. And then it brings up this configuration window. This is where you can set the local ID, which is what we talked about here before, which is for the direct flash method. So if you wanted to change your local ID, you can do that here. And you can also change the bitrate at which the controller will look for the communication messages from Winflash. So if you wanted to change it to 125, I could do that here, and then click Set. And then it says bitrate was changed, and you must reset the controller for it to take effect. So I'll click OK, click Exit. Let's see, when Winflash parameters was changed and not written to the server. That would be the local ID, so we're going to ignore that because I didn't want to change it. So it's still 1. So I will turn off the controller to reset and get the new bitrate in there. And now if I do configure node again at 125, it should bring it up. And there it is at 125. So that's how we would change the actual bitrate that we want to flash at. Note that this is different and does not affect the bitrate that your program is set to communicate under normal operation. This only affects the bitrate of the flash loader. Okay, so now moving on to the actual flashing of the controller, we've got search nodes and flash nodes. Search nodes is for if you do not know your local ID. It'll search all IDs. It'll just search the bus and find any flashable devices. If you know your specific ID and you only want to flash to that ID, you can use flash node. So to start off, I'll show you the search nodes method so we can see how that works. So I make sure all my parameters are correct, make sure my start time is the one I need, and I will turn off the controller, click search nodes, and then turn on the controller before the timer runs out. It says number of nodes found was 1, and it shows the IOXP here was found on local ID 1. So I'm going to check that, and there's two ways we can do this. We can click use, and then that will just set this up for use of that ID. And since the controller is now already in the flash loader mode, it's in the bootloader mode, I can just come here and click flash node, and I don't need to cycle power since it's already in the bootloader mode. So it's going to try to flash, and this window comes up when there is no device information entered in the hex file. It's not necessarily a problem, but you just need to make sure that this is actually the file that you want to flash to this particular controller. So I know this is an IOXP hex file, so I'm going to click ignore this time and just continue flashing because I know that it is the proper hex file. So I'll click OK. It tells me I'm erasing these sectors, and here's the actual progress. So the flashing is completed, and it now asks me if I want to start the program, start all the nodes on the network, or do not start and stay in sleep mode. So I can just click start program, OK. I hear the relay click, and that tells me that the program is running. And that was a successful flash using search nodes method 1. Now the search nodes method 2, again I'll turn off my controller, click search nodes, turn it on. The second method would be to click the desired node here that it found, and then directly click flash nodes instead of clicking use. So the first time I clicked use, and then we had to click flash node down here. This way we can just check the box and click flash nodes, and it'll automatically start flashing. Again, it shows me the warning. I click ignore, and flashing is going to happen, and then it tells me 1 node programmed. So flashing was successful there with the search nodes method. Next we can use the flash node method. So this one requires you to know your actual local ID. So here I know it's 1. Turn my controller off, hit flash node, turn the controller on, and it tells me connected to node 1, and it's going to try and flash the IOXP. Again, the warning pops up, I click ignore, and then it continues flashing just like it did before. So in this case, it also asks me to choose an option here. I'll click start program. The relay clicks, so it was successful. So I'll turn the controller off here, and I'll show you that one of the problems that can be run into is if you don't know the local ID, or if you have the incorrect local ID, and you try to use the flash node method. So if you click flash node, turn your controller on, it'll say local ID error, no response, could not wake up node. And this tells you that you've got the incorrect local ID set. So to fix that, just choose the correct local ID and try to flash again. And then here's the success window or the window that shows us we have successful communication. Click ignore and it'll start flashing again. Okay, another problem that you could run into is the company ID. If you have the incorrect company ID and say I tried Y3 instead of Y2, and I click flash node, turn my controller on, we can see it says error company ID. So that tells us we have the wrong company ID. Come in here and change it to Y2. Click flash node again, and we should have successful communication here again. So this time I'm going to click abort just because I don't want to flash. Let's see, another problem that is typically run into is again the bit rate. Someone is trying to use the incorrect bit rate. Say we've got 500. And we try to flash. So we'll turn off the controller, hit flash, turn on the controller, and in this case you may actually hear the relay click because in the previous problem situations I was talking about with the local ID and company ID, I had the correct bit rate, which means that the communication was established between Winflash and the controller. So the controller got into the bootloader mode, but it didn't actually flash because of a problem with either the local ID or the company ID. when you have the wrong bit rate, there is no communication established between the controller and the program, Winflash program. So your program will automatically start once you turn the controller on. It will not catch the bootloader mode. So just try refer to a manual or try different bit rates here. Again, 125 and 250 are the most common. And we'll try it again. So flash nodes at 125, turn on the controller, and we've established communication. So just be sure that when you flash, you do not interrupt power or anything in the program while it's flashing. This can cause some problems during flashing, so just do not cut power while it's flashing. And at this point, you should have successfully flashed your controller. One thing to make sure is that you've got proper CAN termination on your CAN bus. If you're unable to have any communication after trying all of these things and you still have trouble, please check the CAN termination, the resistor on your bus. So it should be either 120 ohms on each end of the bus or 60 ohms total on the bus. That typically solves most issues. And at this point, you should be good to go to flash your controller. Thanks for watching this training video, and we will see you in the next video. Thanks.